Assalamualaikum warahmatullahi wabarakatuh. My name is Nolana Aida binti Musa, matric number JF200119. And for today, our group, which is Group 7, will present about traffic noise assessment in Bernard Johor Bahru. Our group members consist of 5 people, which is Fatih Nur Aina, Jaswin Nur Atika, me, Nolana Aida, and Nur Maghfirah. Chapter 1, Introduction. The increased use of ground transportation due to population daily demands has been linked to urban noise pollution in the form of increased traffic noise levels. Transportation noise, which include road traffic, rail traffic, and air traffic, is the primary cause of environmental noise pollution. Next, Objective Project. The aim of this project is to collect data of the traffic noise decibel from motorcycles, cars, and lorries into different times and days. Second, make specific evaluation of traffic noise levels and understand the actual condition of noise pollution. Third, calculate and analyze the collected data.
My name is Nuratika binti Kamari and I will present methodology for this study. School is the ideal institution to provide children with the skill and knowledge they will use in the future. Unfortunately, road noise might disturb the learning process in the schools because the majority of schools are located along the street side. Based on the Malaysian Automotive Association, the number of new motor vehicles that have been registered on year 2021 was 249,129 units in the first month, larger than the same period in year 2020, which is 173,545 units. It shows that the use of motor vehicle in Malaysia is increasing. Next, the standard procedure. The standard procedure is based on Department of Environment. The material used to collect data is Class 1 standard, that is SL4033SD, and Class 2 is HD600 data logging sound level meter. The microphone position was located at 1.3 meters above the ground and was mounted on a tripod with distance of 7.5 meter. The microphone was positioned 70 meter from traffic light. The data collection was conducted for 3 peak hours, which is morning peak from 7 a.m. to 9 a.m., afternoon peak hours from 12 p.m. to 2 p.m., and evening peak hours from 5 p.m. to 7 p.m. with 1 minute of interval data measurement. Next, measurement procedure. The data was collected using application that must be installed in device such as my phone. The application was whole 1.5 meters above the ground level and the application was located 7.5 meters from the nearest travel lane center. It was carried out for 2 days during morning peak hours starting from 7 a.m. to 9 a.m. and evening peak hours from 4 p.m. to 6 p.m. For precautionary measure, avoid collecting data on windy and rainy weather because it will affect the efficiency of sound meter level, and the location sound meter application are not too far and not too close to travel lane center. Also, choose the sound meter application that has high efficiency. Lastly, assessment of traffic noise. Traffic noise index were calculated based on hypothesis testing. For this hypothesis testing, claim was made and state the hypothesis with the testing to verify and determine whether the claim is true or untrue by using null hypothesis and alternative hypothesis. Z calculated can be obtained using this formula. Then, Z calculated must be compared with Z critical. Z critical can be obtained using significant level and must refer to the Z table. If the Z calculated fall in the Z critical area, H null must be rejected and H alternative will be accepted. If Z calculated does not fall in the Z critical area, both H null and H alternative will be accepted.
Assalamualaikum and hi, my name is Fatimah Aina binti Razama and I will present about the data presentation for this study, which is about the traffic noise. The data of this study that we get from the field study can be concluded as the table shows. This table shows the data for the day one, which is including the frequency of the types of vehicles, which are car, motorcycle and lorry, that has the traffic noise as shown in the table. Same as for this table, it shows the data for day 2. Next, from the previous table, we can conclude that the data into a histogram frequency graph, as shown in the figure, is one of the example data from this study, which is the histogram frequency of the data of traffic noise of motorcycle on day 2 during AM and PM.
My name is Nolana, and again, I will continue to present about our Chapter 4 analysis and results. Frequency distribution curve and box and whisker plots. The first example is in data 1, which is motorcycle data that has been collected in the morning. From the stem and leaf and frequency distribution curve, the data is skewed to the left. And by using the formula, we got the upper interface 100.5 and lower interface 56.5. And there is no outliner in this box and whisker plots. The second example, which is from data 2, the frequency distribution curve is normally distributed, and from the box and whisker plot, 86 is the outliner because it is greater than upper inner fence. So our new max is at C3. For the last example, the frequency distribution curve is skewed to the right, and it is also from data 2. As you can see, 86 and 87 is greater than upper inner fence, which is 84. So our new max is 84. And for the rest of data set, it is also being calculated and analyzed by the same method.
Hello, my name is Mafira. I will continue with the mean and percentile. So I will choose one example to show how to calculate the mean and percentile. This is all the data. This is the sample, the number of sample, and this is the value. This is the frequency. The first one, we need to find the mean. So how to find the mean? Mean, we need to sum up all this value and multiply with the number of sample. Then we get 81.29. Next, we calculate the percentile for 25 third, 50 third, and 75 third. How to calculate the value? The first one, we need to find the location of the percentile. How to find the location? We use this formula. First, 7, n is number of samples, 7 plus 1, 8, times with p over 100. P is the percentile, 25 over 100. Then we get the location, which is 2. So the value is 80. Same way with the 50 and 75 third. So for the 50, we replace the value of P with 50. So we get the value of 4, the location of 4, and the value of 82. And 75 third, we get 83. Next. So this is the summary for the mean and percentile. The summary for data 1, this is our nominal data for AM and PM for motorcycle, car, lorry, and this is the mean percentile. So all this value for data 1, and this is all the value for data 2.
Okay, next I will explain and elaborate about the inversion statistic of this study. So for the inversion statistic for this study is about the hypothesis testing. Hypothesis is to test whether the claim of the study is true or untrue by using the z-test and f-test. Z-test is for the data that has n is greater than 30 and t-test is for the data that has n is lesser than 30. So for this study, example of the z-test for this study is which to determine that it is claimed that the lorry has higher mean of traffic noise than the car for both days. So based on the table, we can state that H null is mean lorry is smaller than mean car and H alternative is mean lorry is greater than mean car. By using the significant level is 0.05 and based on the Z table, we get that Z critical is equal to 1.65. And by using the Z equation, Z formula, we substitute all the value and we get that Z calculate is equal to 7.424. By look at all the calculation, we can conclude that Z calculate is greater than Z critical and we accept HA and we reject H null since Z calculate value is for at the rejection area. And HA reasonable to conclude that the lorry has higher mean of traffic noise than the car for both days. Next is f-test. For this study, the f-test of the data is calculated by using ANOVA test using the Access software. It is a hypothesis testing to calculate the equality of two or more population mean by testing the variation of the sample. So based on the frequency table and the histogram frequency graph that we get from the data of this study as shown in the slide, we can calculate this f-test. For example, which is to determine that there is difference in the variation in the traffic noise of car on day 1 and day 2. So by using Access software, the ANOVA test is calculated. And using the significant level is 0.05, we get that F calculated is equal to 1.416 and F critical equals to 1.52x. And we can conclude that F calculated is smaller than F critical, which is it does not fall in rejection area and we does not reject H null. We reject H alternative and we accept H null that there is no difference in the variance of traffic noise of car on day 1 and day 2.
My name is Jaswin Murigia. Today I will present about discussion and conclusion part. Discussion. We are collecting data of the traffic noise dB from three types of vehicles which are motorcycle, car, lorries. We are using two different times AM and PM and different day to collect the data to do our project. The category of this statistic is descriptive statistic because we are collecting the traffic noise data from Jalan Pari Ismail, Bernur Johor. We assume that the data type is quantitative variable data and continuous data because the variable we are using is numeric and can be measured. This table shows the information that we gather in day 1. In this table, we can see the key value, median, Q1, Q3 distribution curve, upper inner fence, lower inner fence, and minimum and maximum value for our vehicles. In day 1, we get the distribution curve all skew to the left. And in day 1 also we got two outlier which is for minimum value at lorry at AM 80 and for maximum value car at PM 86. In day 2 also we can see the key value median Q1 Q3 distribution curve upper inner fence lower inner fence minimum and maximum value. In day 2 we got the distribution curve. In morning all are skewed to the left and in evening for motorcycle we got normally distributed, at car is skewed to the right and at lorry is skewed to the left. For day 2 we got so many outlier which is for minimum the lorry at PM is 80 and for maximum value the motorcycle at AM is 84 and motorcycle at PM 83 and car at 84. Conclusion. Traffic noise pollution is a serious problem that affects the overall quality of life. The main factor that contribute to the noise pollution is the noise from vehicles during peak hours, so there are a lot of vehicles in the road at that area that contribute to the highest sound level. In order to reduce the noise pollution to the environment, there are various ways can be implemented where noise barrier is one of the most environmental noise mitigation measure. The government should construct the noise barrier at the main road because the noise barrier, also known as sound wall, can protect from the noise pollution that are coming from the vehicles. Other than that, to prevent this noise problem, the government plant more trees around the road area because it can help in reducing the noise pollution since trees can be absorb excess sound to a considerable extent.